Yeah, thank you. Thank you for this introduction. So yes, sorry for those couple of minutes of delay. We had small technical issues. And due to those technical issues, unfortunately, I will need to skip my demo that I had prepared because I'm forced to show presentation from another machine, but it's fine, I hope. Yeah, my name is Chris. I've been doing quite a lot of stuff in F# open source community. I'm mostly well known from the project called Ionite, which is a set of plugins for Visual Studio Code for F# that brings transforms and Visual Studio Code into full F# IDE that's working cross-platform and things like that. And I've done also a bunch of other open source F# stuff. If you would follow me on Twitter, I'm really vocal about open source methodologies, open source sustainability problems, about developer experience, developer tooling, things like that, and about photography. I'm into photography a lot. So why F#? This is mostly Scala conference, a lot of talks on functional track are about Scala. So I want to say a couple of words about F# before going any further. So F# is a functional first programming language on .NET. This used to be a bit of problem because .NET used to be Windows centric and Microsoft, Windows only, Visual Studio, blah blah, boring stuff. Fortunately, since a couple of years, Microsoft has been changing their strategy regarding the .NET in general. So they started developing .NET Core, which is the brand new open source, fully cross-platform framework, which is definitely from Microsoft's point of view a future of their development platform. And F# is there out of the box as one of the 3 possible languages: C#, Visual Basic. Haha, no one is using Visual Basic. Let's not joke. And F#. So it is type-safe language. It's based on OCaml and on ML family, the family of languages called ML that's been around since 60s. It's focused really on pragmatic approach to software development in just getting things done and focusing on getting things done rather than thinking about diving a lot into category and especially functional programming, category theory, theoretical concepts. You probably won't find them in F#. So if a lot of people are telling me that this is a disadvantage of the language, but at the same time, it just enables us to focus on getting stuff done rather than discussing stuff endlessly. It has a couple of really fancy features, and one I want to mention is something called computation expression that I will show in a moment. This is really interesting feature. It has great community from my point of view, so I like to say that I came to the F# for a language because I was interested in new programming language, and I stayed because there are great people, because I could, if I was just nerding languages, I could definitely go to Haskell and do something more fancy from just theoretical point of view, but the community is something that made me stay in F#. So if you've never seen F#, I have a couple of slides with some small intro. So first of all, what is interesting is that even though F# is a strictly typed, statically typed programming language, you very rarely need to actually specify types in code. F# has a feature called type inference. It's global type inference. So basically, it attempts to figure out the types of the expressions for you. And it works pretty well in practice. There are some limitations, mostly around interrupt with .NET Framework and object-oriented world, because basically object-oriented method overloading breaks any type inference algorithm that there exists at the moment. So there are some issues with that, but if you stay into in F# world, in more functional programming world, functional first world, then this works pretty well. So yeah, and the second really well-known thing from the F# is a pipe operator, and this basically is a pipe similar to Unix pipe, so it takes something on the left and put it as a last argument of the function call on the right. And this allows you to write the code that's really nicely formatted with those set of these chains of the piped operations. And this means that you read code from left to right, from top to bottom. So this is exactly how you read your normal text in English, which is really nice change from braces and the stuff that's actually invoked first in object-oriented languages like C#, that it's actually somewhere at the right, because this is like the first thing, then you go to something that is around that and so on. So this makes a flow of your code totally different. It has algebraic data types, so it has record type and it has discriminated union. Discriminated union is kind of similar to the case classes in Scala. I'm not really too much into Scala, but yeah, it should be similar. So what discriminated unions represents a choice. So for example, here we have type shape, and it can be either circle, and circle can have such set of information. It can be rectangle, it can have some different information, it can be something else. What is really nice is the fact that you have in F# you have exhaustive pattern matching. So if you pattern match on the something that's shape, compiler will force you to handle all cases. So it removes one of the typical set of errors that you've added some new implementation of interface or something and forgot to handle that. With this, you don't have such problems. And there are also records, which are under the hood compiled to normal C# classes, but they have a couple of additional features. They are immutable by default. They provide a way to compare and default equality based on structural equality. So not on comparing the pointers and the address in memory, but if I have two instances of the model, then the equality operation will check if property 1 at the one instance is the same as property 1 at the second instance, and so on, so on, so on. So it's like structural equality, which is pretty cool. And asynchronous code is using those computation expression feature I mentioned briefly. And computation expression is an ability to enhance a block of your code with some additional functionality. So for example, here we have this block of code that looks pretty normally as a normal F# code that you would normally write as a synchronous code. But because you put this async thingy and those curly braces around that means that this code will be executed asynchronously. So it's almost normal code because it actually introduced those two additional things. One is doBank and letBank operations, and those works like async await from C# or modern JavaScript. Yeah. What is really nice, again, is the fact that this is a mechanism that can be extended by the users. So async is part of F# core, async computation expression is part of the core library, but you can create your own computation expressions. It's not a compiler feature, like fact that here is async code and something that works like async await, it's not implemented directly in compiler, which is huge step up from, for example, C# where async await in C# is implemented as a compiler feature that it had to be a new version of the compiler. You don't have ability to implement anything like that on your own. Here with a computation expression, yes, you could do that. On the other hand, the second part of the title of this talk mentions JavaScript. And why JavaScript? Well, first of all, it kind of runs everywhere, but what is most important, it runs in the browser. And I think that this is why one of the main platforms of distributing browser and web is one of the main platforms of distributing applications nowadays. So it's really cool. It has pretty good virtual machine. It's a topic that's not really discussed too often, but JavaScript virtual machines are probably the virtual machines that most money has been put into in last 10 years. And those are like billions of dollars of investments, making V8 better and way better and better than it used to be 10 years ago. So it's pretty good virtual machine, which means that code is pretty fast. And given all the limitations of JavaScript as a language, it's pretty amazing what they do. It has really innovative and open-minded community. So yes, we all love to laugh at JavaScript, and there's like every month there is new framework of the flavor, and we love to laugh at that. But at the same time, the amount of innovation that those frameworks were able to create is pretty astonishing from my point of view. So it's really nice that there is this community that's kind of like just open-minded and looking all the time for new ideas. This obviously is sometimes it's not good because yes, you break stuff, you would sometimes want to use just something stable and hope that it will work in 10 years. But at the same time, the fact that there is a lot of innovation is awesome. It's popular, JavaScript is popular, obviously, it's the most popular language in the world. So having some way to work with JavaScript is good. And it has pretty decent tooling, and not only in terms of like editor tooling, but all additional build tooling, debuggers, things like that. And you can see that I haven't mentioned a language as an advantage of JavaScript. Like I think we can all agree that JavaScript is not a perfect language. It's getting better and better every year. There's like a lot of development into language also, not only with virtual machine, but also in the language. But it's still not a language that people at this conference like. It's not a functional programming language. It's not type-safe language. So there's like a lot of stuff that we would like to have better. And obviously there's quite a bunch of projects that attempt to target JavaScript with some better language. So yes, there's Elm. There's obviously TypeScript, which is super popular. But there are also like functional programming languages like Elm, Reason, PureScript. There is basically nowadays every existing language also has a project that takes this language and tries to compile it down to JavaScript. And it's like Scala.js or ClojureScript, or there's like for C# there are some projects, for OCaml there are some projects, like for every single programming language. And that brings me to Fable, and Fable is F# to JavaScript compiler. It's not a first F# to JavaScript compiler. The concept of F# to JavaScript compiler has been around F# community basically since 2010. And that was one of the first attempts to do something like that. This is like fourth or fifth iteration. What is really interesting about this iteration is that it actually picked up. So previously, F# to JavaScript compilation was always treated as a niche in F# community, as something, okay, the project exists, but no one is using that seriously. Fable changed that a lot. Fable became clearly a mainstream part of the F# community to a degree where it actually drives forward new language features. So there are language features coming to the F# language that are driven just for sake of making Fable better, which is pretty showing that everyone, also Microsoft side, is kind of thinking that this is pretty big deal. Key features of Fable, it's built on top of Babel, the JavaScript tool. So for those of you who are not familiar, Babel is JavaScript to JavaScript compiler. Essentially, it allows you to write modern JavaScript with all modern or even experimental features and target the set of JavaScript that you need. For example, if you run at Internet Explorer 8, and I'm really sorry if you do, but if you do, then you can write this new modern JavaScript and compile down to the old school JavaScript that will run in all browsers and so on, so on. So it's really vastly popular project in JavaScript community. It's a project that a lot of companies are investing into. So it it's a thing, huge thing in JavaScript community. So the fact that Fable is built on top of Babel means that we get all the cool stuff from Babel for free, kinda. And I will discuss that in a moment, a bit deeper. This also provides a deep integration with existing JavaScript community. So there are two approaches when you have especially functional programming languages compiled to JavaScript. There are two different approaches. One approach is try to live in the functional bubble and just say, okay, this JavaScript thing, this is evil and we don't want to touch that. For example, this is a case with Elm. So if you've ever used Elm, you know that the whole idea behind Elm is providing great developer experience in a bubble, and then calling external JavaScript libraries is not really super pleasant experience. Fable goes in totally different way. So it's based around idea of integrating with existing JavaScript ecosystem, with existing JavaScript tooling, with existing JavaScript libraries, because we believe that JavaScript community is in general pretty cool, and working with them makes everyone's lives better. It supports almost all features of the F# language. There are a couple of limitations around some reflection-based stuff, and like type providers are not really supported, but those are like details. Generally, you can take your usual normal F# code, and hopefully it will be successfully compiled to JavaScript, as long as you don't depend on some .NET Framework native calls, because obviously system.io call to handle file modifications in .NET will be totally different in Node.js world, and in browser wouldn't even make sense. So things like that won't be compiled. At the other hand, it provides couple of support for a whole bunch of .NET APIs. So for example, things like string.concatenate are transformed to some kind of string.concatenate that's in JavaScript. Date time type from .NET is transformed into date type from JavaScript, which means that especially if you're if you write your pure domain code, that's kind of okay using some simple types, some default built-in types without doing like web requests or without touching file system. This code probably might be, hopefully, successfully compiled to JavaScript. In terms of JavaScript interrupt, and I will mention that also later, it gives you a tool that creates Fable binding files, which is basically F# file with bunch of interfaces from TypeScript definition files. This is another example of this integration with existing community. TypeScript community has created tons of TypeScript definition files for existing JavaScript libraries. They are in a repository called definitely typed. And you can go to definitely typed, you can take any TypeScript definition file, you can put it into a TypeScript to Fable tool, and it will output you a binding file, which means that it's like this really easy way simple way of integrating with existing libraries. And Fable in general is also focused on developer experience and like getting started experience. There's like a lot of materials for getting started, pretty good templates, so you can do like .NET New Fable Elvish template, and this will create you, if you want to just start with application, with playing with the technology, it's fairly easy to start. So how does it actually work under the hood? And this is really interesting part. So at the beginning you have F# code. It's some F# source files and F# project file that contains all the files. Then you have something called F# compiler service, and F# compiler service is a library that's created, that's basically a fork of the compiler, of official compiler, F# compiler, just with some additional APIs that are focused on creating developer tooling, on creating AST parsers, on creating all different kind of in general, tooling around F#. So using F# compiler services, we produce F# abstract syntax tree. We transform this F# abstract syntax tree in something called Fable abstract syntax tree. Then we transform that into Babel abstract syntax tree. And we feed this final form of abstract syntax tree as a JSON to Babel. This means that Fable itself is just this red part. And this is really not too complex. I mean, this is a lot of code. This is obviously a lot of work, but conceptually, this is not something super difficult. It's basically mapping from one type to another type to another type. So basically, Fable as a compiler can be treated as a function that takes F# abstract syntax tree. At the end, it outputs Babel abstract syntax tree. And then, because we feed that to Babel, Babel is responsible for outputting actual JavaScript code, which means that it will be high quality code because Babel is this super popular tool from JavaScript community. This is pretty cool because for previous iterations of F# to JavaScript compilers were attempting to output JavaScript themselves, which meant that they were not using standard JavaScript module system. They were not using standard way of formatting JavaScript, and so on, so on, so on. So it was really difficult to integrate the output from those previous iterations with existing system. Here, because it's Babel, we just get this integration for free, and this is super, super important. Also, you cannot talk about language to JavaScript compilation without good framework for UI programming in the browser, because even though we can run JavaScript everywhere nowadays, I guess if I'm using F# or Scala and I'm using Scala.js, or F# and I'm using Fable, probably using Node.js on the server is not something I want to do, because if I want to use F# on the server, I can just use .NET. If I want to use Scala on the server, I can just use JVM. So why compile server-side to Node? The big thing is UI programming, is a browser programming, and Fable ecosystem contains this one library called Elvish. Elvish is inspired, as a name suggests, by Elm programming language. If you're not really familiar with Elm, it's a functional programming language. It's really domain-specific language. It's not general usage language. It's domain-specific language focused on creating single-page applications for a browser web applications. And it's really focused around this idea of unidirectional flow of data in your application, which gives you ability to really easily reason about what's happening in your application. And Elvish architecture is implementation of ideas from Elm on Fable, and also not only on Fable, but also there are at the moment libraries that you can use for targeting Xamarin, which is like .NET mobile framework, or WPF, which is like .NET desktop applications framework. But in general, Elvish is based on this model view update pattern. It's inspired by Fable. It's a really great way of writing UIs in pure functional programming way, because basically you model your UI as a set of immutable types and a set of pure functions that transforms either state of your application or outputs view, and I will show that in a moment. So Elm, in principle, changed because UI has always been an object-oriented word, and people were saying, okay, UI is strictly connected to object-oriented programming. Whole idea of object-oriented programming was kind of driven by writing graphical user interfaces, because button needs to be class, drop-down needs to be class, and so on, everything needs to be controller. Elm has changed that, and it's shown that functional programming can be a great way for writing graphical user interfaces. And this idea is getting more and more mainstream, which so the biggest example of that is recent announcements of Swift UI stuff from Apple, which is this new paradigm of creating graphical user interfaces with Swift. And that's more or less implementing ideas of model view update and those ideas of more functional programming way of creating graphical user interfaces, which is pretty awesome. So yes, so Elvish model. You have something called update function, and update function is executed whenever something happened in your application. It takes existing state of your application, the event, and it outputs new state of your application. It's just, again, simple transformation. Then, whenever model is updated, it's fed to the view function, and view function is responsible for taking the model and rendering actual HTML. In case of Elvish, default implementation of Elvish is using React under the hood, so it's not directly outputting HTML, but it's rather using React under the hood, and that's another example of this deep integration with existing JavaScript ecosystem that gives us huge advantages because React is fantastic library and a lot of effort is put it into making it better and better. So demo time, we won't have demo, unfortunately. As I've mentioned, huge important part is this JavaScript interrupt, and there are a couple of ways in which we can do that. So one is there's a whole bunch of APIs that are built in Fable core library that's distributed together with Fable. There is also possibility of generating those external bindings from TypeScript definition files that I've mentioned before. You can also just use import at its simple function call that simulates importing in modern JavaScript. And you can also use dynamic programming if you really want to make your life miserable. How to start? First of all, you need to have both .NET Core and Node.js installed on your machine to start with Fable. Fable doesn't try to hide the fact that it's based on it's kind of in the middle of both those worlds. So it's using both tooling from .NET Core and obviously from Node.js because that's the target. There's pretty good starting guide on Fable.io page. So if you want to check it out, go to Fable.io, and there's like pretty lot of documentation and pretty good starting guide. And also there is Fable.io/REPL, and you can go there and just play with F# and see how to what JavaScript code it's compiled. It's a pretty awesome project. Actually, Fable.io/REPL is using a version of F# compiler that has been compiled with Fable to JavaScript. So it's basically like bootstrapping itself. And it runs totally in a browser. So the F# compiler is loaded, the JavaScript version of F# compiler is loaded in the browser, and there's no server behind this tool, which is pretty cool. Also, another thing I want to mention while I talk about Fable and F# to JavaScript compilation is a safe stack. And safe stack is this idea of using F# both on client and server side, because this is a huge advantage. I mean, using F# just to target JavaScript is pretty cool. It works. A lot of people are doing just that. But there's like even more advantages when you use F# both on server and client, especially advantages around sharing code and type-safe communication between client and server. So yes, it's pretty cool project. It's focused on developer experience. It's focused on making people productive, on good documentation. And SAFE acronym means Saturn, Azure, Fable, and Elvish. And Saturn is like web framework that I created. Azure is, well, you can actually switch that to AWS, and that would be more fun. And Fable and Elvish I've just described. So a couple of links. I guess presentation will be put it online by the organizers, so you will find that online. And yes, do you have any questions? Yes. Yep, here, second row.
Here.
Do you know if there's any plans within the Fable community to maybe target or utilize WebAssembly to any extent?
There are different F# projects that are targeting WebAssembly. There's one project called FS Bolero that's targeting WebAssembly. I think that Fable itself, there is I don't know about any plan that's kind of, okay, we need to move to WebAssembly now. Because let's be fair, this is my personal opinion, but WebAssembly is still, there's long way before it will become super popular and super production ready. So it's definitely, we don't feel a pressure that, okay, right now we need to move to Fable. JavaScript is going to stay for years and years around. So just having ability to target JavaScript ecosystem, I think it's something that we focus on right now.
Others?
Okay.
Okay, great. Can we give our speaker a round of applause? Thank you so much.
Thank you. My name is Chris again, and you can find me on Twitter. You can drop me an email if you have any questions. You can find me on GitHub. 500px if you're into photography, Goodreads if you're into reading books, and I have consulting company. Feel free to talk with me if you need any help. Thank you.